Chris here from Turbosmart. We're at SEMA 2022. This is the Turbosmart booth and we're really excited to talk about all of our new gear. SEMA means a couple of different things to Turbosmart. The primary one is networking. All of our customers are here. We like to catch up with them at least once a year. You can't always fly around the planet and see every one of them individually. So many of them come here. Number two, media. We like to release new products. We're always pushing hard. And the new product showcase is one way to showcase that. 2022, we picked up another 2 trophies. Last year in 21, we also got 2. We didn't know how we were going to do that again, but we managed to. Back to 2018, we picked up our first, another in 19. We technically skipped through COVID. We didn't pick up a trophy, but there was no actual physical SEMA show, so we're going to call it a win. We do have the whole range here, but the spotlight really is the new product. So the pneumatic straight gate is right in the middle of that. So last year, SEMA in 2021, we actually released the electronic straight gate, took all the electronics that we had from the poppet style gate, applied it to a butterfly style zero offset straight gate. We added simple, that was the plan. So we went back to Australia, we really looked at the product lineup, made sure that we were meeting the needs of all of our customers. The electronic product is awesome. It does everything you possibly need to, but there's a lot of setup and a lot of knowledge that is needed to get it to work. So much of the industry knows pneumatics, so we knew that if we took it back down that way, we could really make it a broader product for the market. So traditional poppet style gates have been where it's at for so long, and that's not just for performance turbocharging, it's industrial applications as well. Fundamentally, we believe it's because it's hard to seal, it's hard to do. This took a long time. There was 10 years leading up on the electronic straight gate, and that was to make sure that the butterfly selection was right, that the machining profile could be created where we actually can create a seal, and that the technology existed to physically hold it shut. That took a long time. There was 3 years of dedicated development on the electronic one and the first one to get all of that right, and that was off the back of 10 years lining everything up so that we could do it. Truth be told, the only benefit to a poppet style gate in reality is so many people are comfortable with it. It's been around for so long, and we still have a huge range of poppet style gates. The butterfly style gate, the straight gate specifically, does everything basically better, and that's not to disrespect 5 generations of poppet style wastegates from Turbosmart, but it's just a new way of looking at it. We were able to make it seal, and that took all the benefits of a straight gate into account. So with a straight gate, you're not having to turn the gas 90 degrees. So the efficiency that comes from that is huge. That's why you end up with a higher flowing gate. We get a 50mm valve that easily outflows the 60mm traditional poppet style gate. So that's number one. Number two, it is what they call a zero offset. So it's self-balancing. You've got 100% of the drive pressure pushing on the gate, 50% either side of the pivot shaft. So half it's trying to keep it shut, half it's trying to keep it closed. The thing is in equilibrium almost its entire life. And then you're using the actuator to get the job done from there. Whereas a poppet style gate, the entire surface area at the bottom of the valve is constantly under pressure from the drive pressure. It's always trying to push back. You're always going to have extra spring pressure to get that done. And the straight gate is just a more elegant way to get it done. It's a bit of an accident in R&D. We're on the dyno and the linkage actually came off, or they left it off. We're not too sure which. We're not going to hold them accountable for it. But ultimately what happened was the valve stayed perfectly still through a run on a car that would make somewhere around 300 horsepower. It made about 350 at 14 psi. The gate didn't move the entire run. It was stuck at 14. It actually made it lazier just because the gate was slightly open, but the horsepower was there. The gate didn't move. We logged the position. So that equilibrium of that 50-50 either side of the butterfly shaft in practice is spot on. Effectively, we don't know the full limits of it. We expect it's quite significant. We've done our gas stand testing, but on car, we've seen a 5 psi spring go to 38 psi total with just a simple single port hookup and a 3-port solenoid. So we're talking well over 5 times base mechanical pressure. A poppet style gate is traditionally limited to between 2 and 3, depending on the efficiency of the setup. So we're looking at a much bigger tuning window. That's just, it's by nature of the fact that it's self-balancing. The actuator just needs to move the gate rather than hold back the drive pressure. Our take on it is if you've got enough priority in the setup of the actual wastegate itself, you should be able to run no boost if you want under full load, and that's the key to it. It comes down to how the manifold's set up. I'm not personally a drag racer, but I do know the 4,000 horsepower they need at the top end, they need a fraction of it off the line. So this has given them that control back. The boost-based actuator is a traditional Gen V Turbosmart actuator. It is provided as a twin port setup, so you can have a huge tuning window on top of the huge tuning window that the straight gate actually gives you anyway. So you've got plenty of options there, up to 26 psi worth of base pressure, plus whatever reference signal you want to feed it. The vacuum actuator, we actually released an internal wastegate range of vacuum actuators about 6 months ago. It was in response to the need of some of the European tuning community, like your BMWs and your Minis, where they were just looking for that extra 15-20% more boost out of the factory setup. The factory actuator just physically wasn't big enough to get the job done. There's a few limitations with the vacuum setup in that you've only got vacuum, you don't have more boost coming. So vacuum pumps tend to be fixed at roughly the same vacuum signal, whereas on a boost setup, the more boost you make, the more boost you've got to hold the gate shut. Back to why we gave one to the straight gate, however, and that is a vacuum-based actuator will be open at startup. So whilst a boost-based one is limited to the base mechanical spring pressure, the vacuum one is not. It can be wide open from the minute you start the car, and then you use vacuum to physically close the gate and generate the boost. One of the things that we've realised is one of the strategies for some late model cars is on a turbocharged car is to actually bypass the wastegate, allow the gas through the cat converters to heat the cats up earlier in the morning when you're starting the car. Some of these Mercedes and Mustangs, you'll hear that, quite that loud bark in the morning to get them up and running. It's actually an emissions requirement to get them there. The straight gate vacuum setup will absolutely allow that. You also end up with a much bigger tuning window again, not dissimilar to the electric one. The electric straight gate will give you basically infinite tuning window, and so can the vacuum one. Because it stays open and starts open, you've then just got to provide the vacuum to close against it. That could be a little bit more complicated for some cars to generate a vacuum pump, maybe a canister to store it, but the unlimited tuning window is the goal. We've released an OPR V2, so our Turbosmart oil pressure regulator. We've had one for a number of years now. One of the downsides of the OPR was the return line. So by nature of the regulator style that we used, you needed to plumb back the oversupply or the unnecessary oil back to the sump. Lots of people used it, lots of people loved it. It solved a bunch of problems for a bunch of people, but ultimately it was a real pain to install. We looked at a few different ways to solve that problem. We even looked at caps that had a return fitting so that we could help facilitate the fitment of the OPR. Turns out our engineers had something else in mind, and we were really excited. We're almost dismissive at first, I won't even lie, but once we understood what they were achieving, it was really exciting. We've got a true inline returnless oil pressure regulator. We're able to target 40 psi of oil pressure. It's give or take 10% depending on the grade of oil and the temperature of it. All of the output of that is still well within the spec of what you would need for most, if not all, modern turbochargers and most of the old ones. The difference is you don't need to plumb back the return line. Now, a few people have already asked, it's the first day of SEMA and I got smashed by it within seconds of the show opening. If it hasn't got a return, how can it be a regulator? And it's a good question. Look, there's some secret sauce inside. It is patent pending. I'm not going to give it all away, but I will say, in my experience, innovation is often an old solution to a new problem. If anybody's ever welded before and adjusted their gas pressure, that there is a one-way regulator, as in an inline regulator without a return. The technology exists. It has done for a long time. It did need some tweaking to work with oil, but it's good to go. So we looked at the whole process, and everybody that using this product, you're dead right. The greater majority, if not all, were adding a filter as well. We sold the filter that they were buying a lot of the time. And so we looked at the product. We had a few different options when we were speccing it out, but it just made sense. So the device, well, the product is machined with -4 inlet and outlet. No more fitting kits are needed. So you don't need to buy the extra fitting kit to get it in. It looks, for all intents and purposes, what traditionally an oil filter has looked like for years. The oil filter is built in. It's a 44 micron stainless steel mesh setup. It's fully serviceable, fully replaceable, fully cleanable. And we've also got a rebuild and service kit, which includes the O-rings if you want to start from scratch. We looked at the whole setup. When people are running their oil line for the turbo, they're using this product, what are they doing? We tried to cut down the steps by bringing the -4 fittings or the -4 inlet and outlet onto the same body. You've reduced another failure point as well. There's 2 more threads that have been removed from the equation that can't leak anymore. This one was somewhat of a pet project inside the company. We're enthusiasts for enthusiasts. We all modify cars. We all come across problems every day. There's not always a viable commercial solution for them. So if I can paint a picture, plenty of cars these days need a vacuum distribution block. That maybe they've got one reference off the manifold, but they need to share it with an FPR, a blow-off valve, potentially a wastegate, a boost control solenoid, what have you. A vacuum reference block has always been a neat way to pretty up your engine bay and give you a professional looking solution that sorts sorts that out. On the other flip side of it, you may need to or want to remote mount some of your pressure sensors. You've got these two things that happen in the engine bay. This is where it gets a bit geeky. At Turbosmart, we love a bit of matchy-matchy. I can't lie. The fact that you couldn't, or we couldn't find a solution that looked the same from the same company and mount in your engine bay that kind of matched, kind of bugged us. We felt like they were a very similar product. So we've come up with the mod block kit. So it's a modular reference distribution manifold block. Probably said too much words. And the other side of it is remote sensor manifold. So the sensors are single pass, so you feed the sensor line, so the pressure line from the engine or the source, you got the sensor 1/8 MPT mounted on the other side of it. But on the vacuum block, you've got a bunch of 1/8 MPT ports that you can obviously share with each other in a common chamber. The cool thing that we've done, which we've never seen before and we believe nobody else has done, is we've made it in a modular kit, much like Lego. You can buy it as all vacuum, all sensors, a combo block, or you can buy the individual pieces and build your own, do as many sensors, as many vacuum ports as you want. Like I said, we like a bit of matchy-matchy. We've got the General Lee. So some people might know this car from a bit of fame on a YouTube channel called Whistling Diesel. It's got about 1600 horsepower, twin turbo LS. That car is filled with our gear by the good guys at 316 Speed, good customers of ours. We worked with them early on, a few months back, to organise to get here, and it's been a crowd favourite. A little bit divisive, lots of conversations. It's definitely a attention grabber.